Hey guys, integration by parts. When this technique can be used to integrate functions? Well, the answer is if you are given two functions, two factors being multiplied, like here you have x and cosine of x. So it could be any trig function and mixture with algebraic function, like it could be cosine, sine, tangent, cotangent, and any algebraic functions like x squared, x to the any power, and list goes on. Also it could be other functions like e to the x, exponential functions, logarithmic functions. It could be ln of x, natural logarithm of x. It could be powers of nature of these log functions or e to the x functions. It could be inverse trig functions like sine to the -1 of x or arccosine, arcsine. So it could be any mixture, any concoction. The idea is at this point you cannot apply algebra. You cannot simplify your expression somehow in order to fit it into the table of integrals. You can't. So as a rule good of thumb, you have to use the integration by parts. And there is a product rule for derivatives when you are given two factors, two functions being multiplied. And this is completely different. This is totally different from that rule. That rule is just simply formula for applying. This is a little bit tricky and it's not that straightforward if you compare to product rule for derivatives. And by the way, if you are wondering from there, this formula, this is basically formula for integration by parts, came from, so it derives from the product rule for derivatives, and you could derive it yourself if you have that spare and free time. Now let's get into this. The point is, your original integral has to be broken down into kind of two parts, two pieces. The first piece is your u, and you have to come up with the u. You have to pick, you have to select your u. So for that one, your u is gonna be x, and the way of choosing, the way of picking u, it might be a little bit tricky, and sometimes it's not that obvious, and I would say it takes practice, it takes time to get this, pick this u faster with the time. But for some people there are kind of rules, and sometimes it says what's easier to differentiate has to be taken as a u. And in this case, if you look at your x, the derivative of x is just 1. It's easier, it's more neat. And the derivative of cosine is negative sine. Other people also say then you pick your dv, which is the leftover, the other part. If your second term is easier to integrate, well, as I said, it might be a little trickier when you, especially when you start using and applying this formula. Now, when you pick your u, automatically whatever you have left over, in this case it's cosine x dx, this one is going to be your dv. Alright, so uu is x and your dv is what's left over, so the other part of your integrand, that expression which is in your integral. So your dv is cosine x dx. And again, I'm paying your attention, so this dx has to be taken into consideration. So your dv is not cosine x, it's cosine x with dx at the very end. So that's important. Now, your integration by parts formula, or UV formula, we could call it UV rule or UV formula just for short, requires the product of u and v. We have u, but we don't have v, so we need to find v. And the way you find v, you just kind of go back, since this is dv, so your v is gonna be just the integral of this expression. So it's the integral of cosine x with respect to x. So we kind of get back. Alright, so the integral of cosine is just sine x. So this is your v, it's just sine x. And at this point, you don't have to add the arbitrary constant c. Strange, weird, bizarre, yes, I know. But if you're asking why, it wouldn't matter. You don't need it. It would be too much. So, because we're going to plug your v over here, and this constant wouldn't matter at the end, because we're going to take this integral also. So you don't have to add c over here as is usually, because it's kind of heavy. So we found v, and also your formula requires du. So du, differential of u. So du could be found easily. So all you need to do is just take the derivative from both sides of this expression. And since the derivative of x is just 1, and this one gets multiplied by dx, always. And we could simply just drop this one, it's just dx. So your du is dx. Now we're ready to apply this formula at this point and rewrite your original integral using that what we found before. So go ahead, let's do it. Your integral becomes u times v, u is x, you write x, and you multiply it by v, your v is sine x. You subtract off, minus, take away, the integral, v is your sine x, and du is just dx, since the derivative of x is 1, so dx. And at this point, if you look at your integral and at your expression entirely, what we have, it's much easier, it's solvable, it's integrable. So you just have to drop down your first term, because this is already a part of your entire answer. And this integral is just stable integral. It's much easier what we had before. So since the entire derivative or indefinite integral of sine x is negative cosine, so it becomes positive overall since you have negative in front. And at that point, you have to add your best friend. You have to add this constant c. Well done. And this is your final answer, general solution, general integral for that one. Well, looks okay, this one, but to be perfectly frank with you, things might get more complicated and sophisticated. Sometimes it requires to use integration by parts, this UV formula, more than once. Sometimes you have to use it twice or 3 times. And sometimes you have to manipulate with your expression. Sometimes you need to add the original integral to both parts and do some algebra. But this is completely another story, and that's coming up. Now, one little remark I would like to point out and toss out at you about picking this u, that what I was talking before. There is another kind of mnemonic trick, mnemonic device to remember, to help you, to pick, to select this u. You could come across this mnemonic device and you could use it if you like. And I will just give you a quick glimpse into these things. It's called LIATE. LIATE. Anyway, this is acronym. And first of all, let's just break it down. L stands for log function. It could be any logarithmic function. It could be natural logarithm, log to the base 10, common logarithm. It could be logarithm to any base, put it in a nutshell. Next, I stands for inverse trig functions. It could be sine -1 of x, arcsine x, arccosine x. This goes on. A stands for algebraic functions. So it's your favorite. All these x's, x to the powers, x to the any power, square root of x, any root of x, 1 over L, all your expressions involving including this x. So something like with x. Let me write just f of x. Things go on. T stands for trig. It's your much hated functions like sine, cosine, tangent, cotangent, secant, cosecant. So sine x and so on. And finally, you might guess that E stands for exponential. So it's e to the x, e to the any power. So any exponential functions. It could be any base to the exponent, 2 to the x, 3 to the any power, blah, blah, blah. Now, how to apply, how to use this LIATE. So you start from top and you go down. You go down and you pick your u, whatever comes first in this order, in this direction. So whatever comes first, you pick as a u. Whatever comes second, you pick as the rest, leftover, dv. Now let's put it to the test. So your x is algebraic, and if you go down, if you go that direction from top, to the bottom. So this is your, and you could check, yeah? So x is not log, no. X is not inverse, no. X is algebraic, it's just x. So this is your u. The next function is cosine. So cosine is basically trig, it's a trig function. So this is your the rest dv. So one little thing, okay, true confession. Sometimes when you are given trig and exponential, something like with respect to x, so it doesn't matter what you're going to pick for u and for dv. So this one kind of interchangeable. You could just swap the order. Hope it helps you. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new videos.